Hello, this is Mark van de Wettering, and I am presenting here my Hackaday 1K code entry. It is a project that I dreamed up a while ago. I'm coming up on a sort of important anniversary. On February 7th of 1991, I had my first day at Pixar Animation Studios. Yeah, it's been a great job, and I really love working there. But every once in a while, somebody at Pixar reaches what they call their half-life day, which means that they have spent half of their days working at Pixar. And now, all these years later, I'm coming up on mine. It'll occur on November 6th, I believe, of this year, of 2017, sorry. So I thought I'd make a little clock to help keep me up to date as to when that occurs, just as sort of a fun thing. It's not really meant to be tremendously amazing or anything. Originally, I had intended this to also be a regular clock that would display the current time and date, but I ran into some problems squeezing all that down into 1K, so this is what I came up with. And in the end, I actually think just having a little sort of calendar app that is dedicated, it's kind of amusing to me in some way. This is my prototype. You can see it's all still on the on breadboards and stuff. I have a Arduino Metro 328, which is the target platform. And on the right, on top of the yellow breadboard, is a DS3231, which is an inexpensive sort of $3 from China clock module that's supposed to be quite accurate. They say a couple parts per million. I think that translates to about a minute per year, something like that. Should be plenty good enough for this application. What my thing does is it talks to the Arduino, speaks directly to the DS3231, which has been programmed to keep time. And it's got a little battery backup, so if you unplug this thing, la 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 la, and then you plug it back in, it still knows what time it is. So every couple of seconds it wakes up, talks to the DS3231 and says, gee, what's the date today, basically. It doesn't actually even read the time now. And then it computes the number of days from a particular start date, which is January 1st of 2000. I just used arbitrarily because that was easy, and then figures out how that compares to the target date that you're after, and it displays this message. Now, if I could reset the time on the clock to make it pretend that it's further in the future, but instead I can just change the firmware and reflash it very quickly to pretend like today was the day. So if I pardon me for a moment while I sip around here. So now it turns out that today is Christmas Day, and it's 6,203 days since January 1st. And so if I program this in really quickly and hit a button to reflash it, that's good, then you'll see two things happen. It goes half-life is today, day is today. And you also see that one of the LEDs, both the power and the LED 13 pin has been lit up, which means that I can trigger some external event. I'm not sure exactly what I'm going to do for the external event. I've thought about wiring up a little motor that would wave a flag or something ridiculous. I don't have a lot of space to do anything fancy left. Another possibility is to use one of these. This is actually a 10mm LED. And it's got a blinking circuit built into it, so without any extra code, I could just have this LED blink on top or something. I think I'm going to try to mount all of this in sort of a tube horizontally that would sort of fit nicely with the display. The display is something I got from from Deal Extreme a while ago. I don't know that these are still available. If anybody has a source for these are based on the TM1640 module, and so that's all set up here. Eventually I'll replace the big Arduino with one of these little Arduino minis that I also got from China. So I think this one's a 5V, but if not, I've got 3.3 and 5V ones. Those are also only about $3. So that'll fit nicely into a case. When the day is passed, the project is kind of, maybe I can retarget it for some other nifty dates in the future, but when it's passed, it will show half-life day has passed. So this has been the project. The interesting bits are, it's obviously, if I try to program this with the Arduino framework, the drivers and stuff would be several K of space. I think my early prototype was about 6.5K. To get this down to just 1,008 bytes, which is what it currently is running, I had to not use the wiring library or the library for the TM1640. I coded up my own version of just the bare essentials to drive the LED display, and that works reasonably well. I think technically I'm out of spec. The data sheet for the TM1640 says that the maximum, or that you have to have a pulse width of at least 400 nanoseconds, and I'm not doing that probably. I haven't measured it on my scope or anything, but I haven't had any trouble with this module, so I could actually clock the whole thing down a bit, and indeed it will actually run on the 8 megahertz tiny modules when I'm done, so that will in some sense make it a little better, a little closer to spec. It'll still be off, but I haven't had any problem with making it work, so I think I'm not gonna stress. I could insert some delays. That would actually, I probably have enough space to actually insert enough delays to make it technically in spec. But for a while I was a little bit over even with my prototype, and so I couldn't manage it. But anyway, so I hope that's good. I think this has been it. Let me program it back to the normal date, and I have something like, oops, there we go, 316 days left, and it's been a fun project. I encourage you, in some ways this is silly in that I'm actually using a big stomping 3% or something of the available memory space on the Arduino. It's ridiculous, but it's actually a valuable thing to learn about the low-level hardware that are actually available to the Arduino. Things like digital write have a huge overhead in both in time and in memory. Using the serial ports can have buffering. The Arduino framework does a lot to hide interrupts from you, and interrupts are powerful and useful. So I was thinking about actually making a version of this where it ran off the 32 kilohertz clock that's supplied by the camera or the clock module. You know, you can do all sorts of fun things, and I urge you that if you've been playing within the Arduino framework, that you kind of branch out and try to go a little lower level, see what you can do with the AVR libc libraries, which are really helpful, and see what you can squeeze down. I've really enjoyed this project. I've learned a lot about how to sort of squeeze code. The code is all available via GitHub. If you can figure out your own applications, it's all under BSD 2-clause license, which just says basically credit me and don't blame me. And anyway, I've rambled on a bit long. This is really a very simple calendar project. I hope that somebody finds it enjoyable, and I hope to see all the other 1K code entries. This has been Mark Van de Wettering, who blogs at brainwagon.org and tweets as @brainwagon. Talk to you all soon.